Good morning, everyone. Right, I think we're about ready to start. So first and foremost, congratulations to making it to day 3. I appreciate NDC. There's a lot of great talks, a lot of great speakers, a lot of information. So the brains by the third day are possibly getting a little stretched. So I appreciate you deciding to come and listen to me talk for the next hour. We're going to be talking about designing for change with vertical slice architecture. Now, this is a talk I've wanted to give for a while, but I've always kind of shied away from architectural talks. I think there's a lot of imposter syndrome there. There's a lot of very clever, intelligent people who talk about architecture, and generally I don't consider myself one of those people. But at the end of the day, I've been a software engineer for over 20 years now. I've worked in a lot of different types of company, worked on a lot of different types of product with a lot of different engineers, and I've seen quite a lot of things, and I've seen repeated patterns and problems, and I really wanted to just share my perspective on some of this stuff. So that's really where this talk has come from. It very much is centered around my experience and what I've seen. I'm probably going to talk about things that you might not have seen, and you might not agree with. That's fine. We don't have to agree on everything. But this is certainly problems I've seen, and the way that I've found has been good to tackle those. So just before we get started, I'll introduce myself. My name is Chris. I'm a principal software engineer at Enable. I just want to take a quick second to shout out for Enable, because we actually achieved something quite spectacular at the end of last year. Given the current climate, we actually became a unicorn company with a 1.2 billion valuation. So we're pretty proud of that, and I'm really happy to be working there. I'm also a Microsoft MVP. I've done some blogging. I've written a book. And I do some open source work as well. So that's just a little bit about me. Right, let's get going, because we've got quite a few bits to cover. So let's talk about change. I think it's fair to say that the one constant in our industry is change. There's always something new to learn. There's always something new to try out. And arguably, that's probably why a lot of us got into this industry. We like trying out new things and new technologies and whatever. Arguably, it's also the biggest curse of our industry, because there's always something new to learn and something new to try out. And when we think about change when we're building applications, we often think about things like the technologies we're going to use, the frameworks and the libraries we're going to use, and whatever patterns and practices and things. And these are definitely valid things we want to be talking about, putting in abstractions and things so we can potentially swap things out. They're all valid conversations to have. But interestingly, the biggest source of change in an application's lifetime is the requirements of the application, the business or the customers it's serving. And interestingly, this doesn't seem to be talked about as much, and not as deliberately maybe. And at least in my experience with the applications I've worked on, it's actually the requirements that kill them. It's actually the requirements that stop an application being able to be useful, because it can't change anymore. It can't adapt to the fact that the business has changed direction because of a change in economy or something like that, or a change in business opportunities, or things like this. And that's what end of life an application and ultimately leads to it being replaced or what have you. So really the key thing that we're going to be looking at here is, how do we make applications resilient to that change? Because I think if we can do that, then we're going to have applications that last longer and hopefully serve the users, customers better. Now, I just want to take you back right now to where I started my career. So I started my career in the late 90s, and N-tier architecture was kind of the way that all applications were built, and this is still a very popular architecture today. It's a straightforward architecture. We have a user interface that talks to some business logic, and that has some data access. Now, a key thing about this architecture is it kind of puts the data store at the center of it. And this is great. And certainly in the early 90s, it made a lot of sense. The database was a very important place. It's also kind of scary, certainly as a new engineer, because you had to write these things called stored procedures, and you sent them to these people called DBAs, who usually sent you very snotty emails back about how terrible your SQL was and how very dare you send it to them. And then you would kind of fix it and beg forgiveness, and hopefully they'd run those scripts on your servers, on their servers. And this application, this way of building applications worked really well when I was starting. Certainly as a new person to the industry, it made a lot of sense. But it quickly felt like it was becoming limited. And in the early 2000s, I think it's around 2003, Eric Evans wrote the domain-driven design book, which I sort of picked up along the way. And I really liked that approach to things. It made a lot of sense to me to model software after the business domain it was operating over and things. And then around 2008, Jeffrey Palermo wrote a blog post and introduced this concept of onion architecture. And this really resonated with me because it put the domain at the center and it made it the most important thing that we look at. And the database kind of fell off to the sides as more of just an infrastructure concern. And this made a lot of sense. It felt like a better way to model software, and I was quite a big fan of this. And I did kind of looked at this and I started to play around with it. And there was other types of onion-based architectures. There's sort of hexagonal architectures, ports adapters, and things like this. But really, things cemented around 2012 when Bob Martin coined the term clean architecture. Now, this clean architecture is kind of an amalgamation of various other attempts at onion architecture. It's kind of taking all the best bits, if you like, and trying to push them together and create sort of one super onion architecture, if you like. Now, this architecture is possibly one of the more popular ones nowadays. Certainly, if you go and look at LinkedIn or YouTube, you will find it very hard to not find someone telling you how to do clean architecture or offering a template or something like that. And this is an architecture I've used quite a lot myself, and it certainly is very good, and I've certainly had a lot of success with it as well. Now, if we just kind of start to sort of dip down into a little bit lower level now, I'm going to just use NTIER as the example through the rest of these slides. It could be any of these layered-based architectures, but NTIER fits on slides better, so we're going to stick with NTIER. If we kind of look at what sort of rough structure you would get in this type of application, I'm going to use a repairs application as a bit of an example because I used to build a repair system. So we've got some user interface. That's got the various pages that make up your application, or endpoints, whatever you happen to have. And then you've got some business logic, and you've got some data access. So we've got this kind of horizontal grouping by technical responsibility: data access, business logic, user interface. And if we're Onion, we're talking application services, domain, and what have you. But there's also a secondary grouping. There's a secondary grouping by entity. So, you know, we can see it in the business logic layer, the data access layer. We have this entity called a repair. So we have a repairs service and we have a repairs repository. Likewise, for the job service and the jobs repository, and the engineer service and the engineer repository. And this is quite a common pattern. And, you know, again, I'm not saying this is always what it is, but certainly in my experience, the vast majority of times, that tends to be how these things are put together. If we kind of drill down into these services a little further, we'll see kind of probably what we expect to see. We've got a repair service here, and it's got methods on it that operate over repair. So we can get open repairs, we can get completed repairs. Likewise, for the engineer service, we can get all of the engineers or get a specific engineer by their ID. Again, this all looks very neat and tidy and makes a lot of sense. If we kind of look at sort of the rough, well, an abstract view of what code paths would look like through this application. Again, very simplified, but it looks quite clean and tidy. We've got, you know, our UI is going to talk to a service. That service is then going to, in turn, talk to a repository, and it's all nice and neat and tidy and clean. And at this point, we can sort of sit back at that design, and we can be very happy with it. It looks beautiful. It looks clean. It looks fantastic. And to be honest with you, that's pretty much the same for pretty much whatever architecture you pick in the first year or so. Now, I'm not too bothered about an architecture for an application in the first year or so. What I'm interested about is what an architecture does after 3 years, 4 years, 5 years, 6 years, 8 years. Okay? Because that really is the true test of an application's architecture and how well it's been built. So let's see what happens over an application's lifetime. There's these pesky things called commercial pressures, right? And they have a really big effect on an application. It'd be lovely if we could design these in isolation, work on, you know, features and whatever without any kind of pressures, but the reality is we don't. We're all in this business ultimately to make money. So what are these kind of commercial pressures? What effects can they have? Well, let me ask you, first of all, who here has ever had to rush a feature? Whoever has not had enough time to build it? Okay, so pretty much everyone in the room. I think that's fair. I'd say if, people who haven't put their hand up is, I'm not sure if you're being truthful, but but yeah, rush features, we all have to do it, right? Customers, or usually a salesperson comes along and says, I've sold that feature. I know you said it'd take a month, but I'm going to need it in a week, right? Because I've just landed this big client and I promised them that feature. And things like that. These are things that happen. These are the realities of the world that we live in. Next one is custom functionality. Has anyone ever been asked to build a specific feature just for one customer? Yeah, again, vast majority of you, yeah? That lovely code, isn't it? If customer equals A, then do this, otherwise do this, right? We all feel warm and fuzzy inside when we write that, don't we? So yeah, but again, it's true. It comes along. Customer, big bag of cash, can you please make it do this for me, right? And of course, most businesses are going to say yes, and they should. I get that. That makes sense. And really, what this ultimately results in is technical debt, right? You're going to get that rush feature out. You're not going to be able to build it as well as you'd hoped, right? You're going to have to potentially cut some corners somewhere, and that's going to create technical debt. You might have to, forget about doing a bit of testing. You haven't got time to write the tests. The custom functionality, it's going to make code pass maybe a little bit more convoluted and a little bit harder to understand. That might result in some bugs. So these are kind of the effects that happen on an application over time, and they also compound over time, right? I do like this GIF as well. Sorry, I'll quickly put this in, and I just couldn't help it. But I just can't, forget about the meeting with the PO when they said, you will let us, if you get this feature done for us, and we're like, yeah, we'll get that done as long as you give us some time to refactor. You will, you won't. But anyway, coming back to the layered thing. What I found over the years, and the more teams and the more companies I work for, and the more applications I work with, certainly older applications, is that ultimately these architectures always ended up with the same problems. Okay, given enough time and given enough those commercial pressures, things always seem to go the same way. Ultimately, they became more complex. Now, arguably, you could say that about any system over time. Any system's going to become more complex, which is fair, but complexity can be good and bad. And generally, what I found is this was bad complexity. It was harder to maintain. It was more convoluted. It was easier to make mistakes. It was also much harder to learn. I noticed that as new engineers came on board, they were taking longer and longer and longer to be able to be productive on the system. Now, this is an interesting one because we've actually kind of been dealing with this a little bit ourselves at Enable. We've got a system that's been sort of iterated on over the last 5 years, and we've noticed that we have sort of increased our time for new engineers to become productive. That's gone from weeks to almost a month now. And interestingly, I gave this talk at NDC London earlier in the year, and I had a whole swathe of people come up to me afterwards. I spent the best part of an hour talking to people afterwards because everyone was like, yeah, I've seen these problems. I agree. And one guy was telling me that his company is now at the point where engineers take 3 months to become productive on their own because their system has become that difficult to work on. And really, what we can do here is we can sum all these things up and really say that these systems have become much harder to change. Okay, they can't be changed easily anymore. It's too difficult. So, the question then is, well, what's causing this? What's the problem? Like, where is the ultimate issue here? And I thought about this a lot, and I really ended up summing this all up in one word, and that word was coupling. Okay? Now, in this case, it's high coupling, and it's this high coupling across the system that causes the problems. Now, where's this problem coming from? And ultimately, most of the time for me, it came from services. Now, I'm not a huge fan of services. Now, I'm not saying services can't be done well, and I'm not saying that the idea of a service is bad. I'm just saying that most of the time the implementation is bad. Now, for me, the problem is that services are usually built around this idea of an entity that they're working over. And what this actually results in over time is services that have this high coupling, but they have very low cohesion. They have lots and lots of methods on them that are operating over this entity, but don't have anything to do with each other. They never interact with each other. It's very similar to an API controller, for example, where you have an API controller and all these action methods that never interact with each other. They're just there because they happen to work off of that entity's endpoint, okay? Now, again, I'm curious here, who's worked on a service that's a few hundred lines long? I'm assuming most people are going to put a hand up, yeah. Has anyone worked on one that's 1,000 lines long? Good chunk. 2,000 lines? Yep. 3,000 lines? Yep. I've done a 5,000 line service, believe it or not, right? And we don't like to admit that these things happen, but they're very common. They're far more common than we like to admit, okay? Now, this is going to cause problems. I mean, in fact, if we sort of jump back over to the repair service and the engineer service we were looking at a little bit earlier, and let's pretend that a few of those commercial pressures have been applied and a few years have gone by, those sort of small, tidy services are starting to look a little bit messy now, okay? We've now got loads more methods than we had before, and I've put the little ... at the bottom just to insinuate that there could be even further going on. So this is now, grown in complexity. There is no one here that can tell me that this thing has got single responsibility anymore, right? Anything that's 5,000 lines long, 1,000 lines long, is very, very rarely going to have a single responsibility, right? Single reason to change. So this is a big problem, right? And this is this coupling. There's all these areas of the system calling into this service, calling all these different methods and creating this coupling. There's other issues here. Let me highlight these methods for you. Does anyone see any issues here? Looking quite similar to me. So we've got the get repair by engineer and the get completed repairs by engineer methods on the repair service. Now, they're fine. I don't see too much of an issue with those. But the get repairs for engineer and get completed repairs for engineer methods, not too sure about them. Shouldn't they be on the repair service? Because they're getting a repair. They're just using an engineer as a filter, right? And the reality is sitting here on a slide, right, in this contrived example, yeah, we can see this and it makes, obviously this doesn't look right. But the reality is when you're building software and you might have tens or more of these services going on, you're not going to compare these things side by side. And again, we could sit here and say, well, this is just bad design. This shouldn't ever really happen. But again, the reality is you've got, time pressures. You've got potentially, engineers who are new to the industry coming in and doing things. And, they're working on an engineer profile page that needs to show a little snapshot of the jobs they're working on. And they're like, well, I'm working on an engineer. That's the page I'm working on. So I go to the engineer service so I can get the jobs for them. Now, I'm not saying I agree with that reasoning, but I also can see why it would happen, right? And these things, like I say, compound over time. This is just a small snippet. There's more problems. These two methods, right? Get engineer and get engineer light. I will put money on it that get engineer light is calling get engineer and then just discarding whatever it doesn't need, right? So say get engineer is a really costly call that's joining loads of things together to bring back this big engineer profile, and then get engineer light just wants the name and their trade, right? So it does all of that and it just throws everything else away and just returns those two. Again, it seems crazy that that might happen, but it does. It does happen, okay? And if we kind of look at that kind of abstract view of our code paths now, it's not looking so pretty. And again, this is that coupling happening over time, and usually, like I say, services are usually the thing that is responsible for this. So a page is now having to call multiple services. Services are now potentially operating over different entities. So now we're injecting different repositories, and all of a sudden, everything is kind of linked to everything. Yeah? And this is going to cause a lot of problems. So if we kind of think about what that might be doing to the application at this point, well, we're probably going to be seeing one or more of these problems. We're going to be seeing a rise in the cost per feature. Now, this is a really interesting metric. I'm not usually a huge fan of metrics around engineering teams. They tend to be used to kind of beat engineers over the head a little bit. But this one is actually quite valuable. Because as an engineer, if you see this increasing, it's a good warning sign that your application is starting to become harder to change. Now, the other thing is you're probably going to see a rising bug count. If we think about all those cross calls and everything, changing anything is probably going to have some form of side effect somewhere. If you don't fully understand every single side effect that's potential from your change, you might introduce a bug. This is the kind of classic, we change something over here and this thing over here breaks. Now, some of you might be thinking, no, but Chris, surely we've got tests to cover that. That won't happen. Yep. See that technical debt that we talked about earlier, right? We might be seeing performance issues as well, that get engineer light method, okay? That sort of thing. We also might be putting other abstractions in here, right? We might be putting in facade layers because all of a sudden it's got too difficult to kind of reason everything that's going on, so we'll make it simpler, we'll put a facade in front, and now we've just got a simple call, except it then underneath and goes mad, right? And we don't really fully understand necessarily everything that's happening there. And the other thing as well is, as I've mentioned previously, we're probably going to see a rise in the time it takes to onboard new engineers. And if you're a company that's trying to scale, trying to grow quickly, this can be absolutely crippling. And ultimately, really, what I'm describing at this point is a big ball of mud. So, if these are the problems, what are the solutions? Well, I thought a lot about all of this, and I was like, well, what's really bothering me here is that we don't build software in layers. That's not how software is built. Maybe I can prove that. Has anyone here been asked to build a data access layer? Yeah? Or a business logic layer? No. Doesn't really work, does it? POs don't tend to come to you and ask that. What they tend to do is they come to you and say, I would like a screen that lists out all of the engineers, right? Or I would like a screen that allows me to create a new repair. Now, interestingly, those features, those capabilities that they're asking for are not based on layers. They're based on a transition through all of the layers. So, is there a better way? Well, unsurprisingly, at this point, I feel there is. And that is vertical slice architecture. Now, vertical slice architecture has been really interesting for me. I was working with a team, and we were building stuff using clean architecture, and we were seeing all of these problems that I'm mentioning. And we'd started to do things that, unbeknown to us at the time, actually were moving us towards this vertical slice approach, and I'll sort of touch on that slightly later on. But ultimately, I sort of one day stumbled across this talk from a guy called Jimmy Bogard, and some of you may know him. He's a speaker here at NDC. He's done a talk over the last couple of days, and Jimmy was talking about this, and he was talking about his experience as a consultant and sort of all the applications he'd worked on with all these different teams, and he was describing all of these problems that I've been seeing over the years, and then he started talking about vertical slice and how they'd kind of done that. And this just kind of was like a penny drop moment for me. I was like, this makes total sense. I could see that we were moving towards this anyway, and this was just leapfrogging us further forward. So for you all, the question is, well, what is vertical slice architecture? Well, I'm going to sum it up by saying that it's simply organizing by a use case and not by technical responsibility. It's probably the quickest way I can sum it up. We're not looking at layers here. We're just looking at these capabilities of a system and grouping things in that way instead. And this has some interesting benefits. So if we think to our layered architecture, right, and again, as I'll just remind you, it doesn't matter if this is one of the onion-based ones or this one. It doesn't really matter. We've got these layers grouped by technical concern. Now, in a vertical slice application, what you're going to do is you're going to see folders that are named after the capabilities of the system. Now, I'll show you a code example later on, but for now, if you think of a .NET project, you're just going to essentially have a features folder, and underneath that, you're going to have a load of folders that list out the capabilities of your system. And then within each of those folders, clicked in the wrong place. Within each of those folders, you are going to have everything that's needed to fulfill that feature. So that might be some UI, it might be some logic, data access, it might be API endpoints, whatever it needs to be. But the point is, everything for that feature is in that folder. Now, I'm going to say brace, brace. This is a saying I've stolen from a ex-colleague of mine. She was Italian. She used to say this right before she'd say something contentious. And I'm going to talk about code sharing now. So, one of the key tenets with vertical slice architecture is that we don't share code between our verticals. Now, this tends to hit a nerve. Interestingly, every team I've introduced vertical slice architecture to, almost the first question they've had to me is, but how do we share code? Now, this is an interesting observation, I think, in our behavior, that the first question we want to know before we even know what we're building is how do we share code? We put code sharing on this huge pedestal, and it's kind of been seen as this great way of building software that we make so many things reusable. But in my opinion, at least, I would say that code sharing is probably one of the most dangerous things that you can do as a developer. Don't believe me? Code sharing is what led to that. Now, do I say that all code sharing is bad? Absolutely not. That is not what I'm saying. And is there the room to share code in vertical slice architecture? Yes, of course there is. Absolutely. And I'll talk a bit more about that later on. But for now, and I tend to do this with everyone when I'm talking to them about vertical slice for the first time, is it's better just to think of, no, you don't share code. And that's largely just to try and break this mindset of sharing it by default. Now, the advantage of this is that our verticals stay self-contained, and we don't have them interacting with other verticals, which means that we get low coupling and high cohesion, which is exactly the opposite thing that we were seeing when we were using these services earlier. And low coupling and high cohesion, I'm pretty sure, is a fairly good trait to have in software. It gives you a lot of flexibility, it gives you a lot of ability to change. It also has a lot of other benefits as well, and we'll touch on those as we go. Now, this slide I wanted to put in is, frankly, it's not strictly, it's not just applicable to when you're building things with vertical slice. This is probably applicable with however you choose to build your software. But I kind of agonized over this slide a lot, and I still played with it last night, but I've gone with code for what you know. I didn't want to put something like keep it simple or code for simplicity, because frankly, sometimes there are complex problems that need complex solutions. But what I'm really getting at with this slide is not coding for things that you don't know about, right? So the Yagni thing. Don't go and put abstractions in because you think one day you might want to do something, because chances are you'll probably get the abstraction wrong, or you'll make it so generic that it's pointless. Likewise, if you're putting code in because, oh, we might want to do this in the future, right? Well, wait for the future to come and see if you do want to do that, because that code has got to be maintained. Okay, that's something that someone else is going to come along and look at in the future and try and decide if it's something they should change or shouldn't change. Is it being used? Is it not? I don't know. What's it here for? Right? So with vertical slice, you really want to stick to this. And vertical slice, I think, allows this to happen much more because it's so much easier to change things. And we'll talk, and again, we'll see how in a little bit. And just to kind of really hammer that point, I would always go as far as saying it's far cheaper to have some duplication in your application than it is to have wrong abstractions. Now, one of the nice things with verticals is that you get this ability to design each feature optimally. Now, some people aren't too much of a fan of this. People like to say, well, everything that we do should look exactly like this, right? Which I get, it makes life easier sometimes, it makes things repeatable, but I think in the real world that doesn't actually make sense. You know, why should I have to go through a load of layers to do things when I could just do a really simple call, right? And that's something that I really like about vertical slice architecture. So this is slightly contrived, so bear with it, but you know, if we've got a few different types of use cases, we can really just build exactly what those use cases need and nothing more and nothing less. So, for example, if we just have sort of some CRUD-based UI, we can just have some UI that's going to potentially call some logic to just pull something out of a database and it can get rendered on the screen, or save it if it's posting a form. If we've got a use case where we just need something put on a queue, for example, we can just have some UI and some logic that pushes something onto a queue or onto something like Kafka or what have you. Likewise, if we have a Kafka consumer, for example, we can just have something that consumes it, an event, and pushes something straight into a database. If we're doing like shadow copying between microservices, something like that. We might have a use case for, say, APIs where we want to save something to a database and emit an event or a domain event, whatever that happens to be, and we can do just those things. And we can make sure that each feature has just got what it needs and nothing more and nothing less. Now, I want to talk about developer productivity. One of the things I noticed all the time with layered architectures was a decline in developer productivity over time. Okay? As things became harder to change, features took longer. This is that cost per feature metric that I was mentioning earlier. And what I've noticed with vertical slice architecture, having used this at several companies now on several different types of product, is that just doesn't seem to happen. Things seem to stay relatively consistent. And that's largely because we're not creating lots and lots of coupling as we go along. Now, to give you a real-world example of kind of this in action is at Enable, we launched our claims product earlier this year, and this is the first time we've used vertical slice architecture within the company. And we actually got to do a load of things that we've never been able to do before. So first of all, we iterated and built features far quicker than we ever had before, because we were just building just what we needed at the time. We weren't putting loads of abstractions in. We were waiting for these to appear, and then we were refactoring as we went. And this allowed us to get something built far, far quicker. This in turn meant we actually could launch an early adopters program for the first time and actually get this out to early adopters and get early feedback while the application was still in its main development cycle. And this led to improvements in the application, and ultimately this led to a far better product at launch. In fact, we had one of the most successful product launches we had, and at this point, almost every single customer has decided to take claims on as a new product. So this was a huge success for the company, and I'm not saying it was purely the vertical slice approach that led to this. There were definitely other things that we changed as well, but this definitely had a huge impact on the engineering teams, and we were definitely able to iterate and move things along a lot faster. We've also ended up with a code base in a much nicer state at the end of things. We have tests. Now, another thing that I've found with vertical slice architecture over the years is it's much easier to learn. And that's because each one of these verticals is self-contained. So if we kind of think back to that kind of layered thing that we were looking at earlier, to make a change somewhere to adjust a feature, we might be touching quite a lot of areas of the system in order to do that. You know, multiple services, multiple repositories, or whatever it happens to be. And this made me think, because a couple of years ago, I read a fantastic book from Mark Seaman called Code That Fits in Your Head. If you've not read that, I would definitely recommend it. It's a fantastic book. And it talks in there about research, about how many concepts humans can keep in their head at once. It turns out the answer to that is 7. And what I found is that in these large systems that are based on layers, to get to 7 concepts really, really quickly. Okay? And that's really where we end up in this situation where we have got bugs and we end up making mistakes and things like that. With verticals, though, because these features are isolated, say we need to go in and do some work on feature F, for example, we can go in and we can just look at feature F. Everything that's for that feature is in that folder. It's all together. We're not going off and looking over 20 different projects and trying to find all these things across all these different files, scanning our 5,000 line service for that one method we need to change, that kind of thing. It's all there self-contained. And we can kind of learn the system as we go to some degree. I'm not saying you should do that, but like you could do. You could, as you work through each feature, you're learning a bit more about the system and you're kind of just grokking it as you move along, rather than necessarily having to absorb everything in one hit just so you can make that one little change. Another thing about vertical slice architecture is it makes things much easier to decompose. Now, I'm a big fan of monoliths, right? I like to start off with monoliths. I think microservices definitely have their place, but I definitely think they get overused. And with vertical slice, I think it's a great way to start building applications, because you can build them monolithically, and then if you find that you have parts of your application that need to scale independently, you can break those areas off and do that. So you can take features, and then you can just carve off the bit that you need, and then you can go and run that separately somewhere and scale that independently. Now, this is kind of looking at similar concepts to modular monoliths, and my friend Layla Porter, who's in the second row here, did a fantastic talk on that yesterday. If you're not seeing that, please watch that on YouTube. But this is a really powerful tool, because we get all the speed of building with a monolith in the early days of an application, but as it grows over time, and hopefully we've got this really successful application that lots of people are adopting, we can start to split it apart. And we don't get that premature splitting that sometimes you get when you try to use microservices from the start and you get your boundaries wrong. Okay? We can do this based on what we know. Now, there is a bit of an omission on this slide. I've not talked about databases. And I've been asked about this several times when I've given this talk. So I don't put databases on here purely because that bit's hard. So, yeah. No, it is hard. I'm not gonna lie. It is a hard bit, but the reason I've not really put anything here is it really does depend on. I'm trying not to sound too much like a developer at this point. It really does depend what you've done with your database and what type of database you're using. So, say for example, you're using a document database like Mongo or Cosmos or something, right? You will probably find that pulling that apart is going to be much easier because your documents haven't got joins between them and things. But again, that's going to depend on how you've done it. If you're using a SQL database, and you're using sort of a monolithic, single schema or whatever, then that's going to be hard. Definitely, you're going to have to work out how to pull those bits apart and separate off the tables that you need, and that's definitely tricky. If you're using something like domain-driven design and you've modeled your application in that way, chances are what you're splitting off here is a subdomain, and hopefully what you've done is you've got schemas that match your subdomains. And hopefully you can just pull that schema out and it can just come along with the features that you're pulling over and just move over. And that could be quite easy. So it all really does depend on what you've done with your database and how you've structured your data. Okay, so that one, unfortunately, I can't give a huge amount of advice other than what I've just said. Right, moving on, flexibility. This is another really key point with vertical slices. Obviously, I've talked a lot about, obviously, the theme of this talk is change. Obviously, flexibility is important. But in this case, what I'm talking about here is flexibility around how you work with features. So if we've got some features here, and again, I can kind of use a real-life example here when we were building our claims product. We built a feature that we thought users would like, and we got it out to our early access customers. And what we found is they really liked the idea of the feature, but the way we'd implement it just didn't work, right? It wasn't a great way of doing things. Now, what we could have done is go back to, say, feature A and gone, okay, well, we're just going to rewrite, 99% of what we've got here and da-da-da-da-da. But another approach that you can use with vertical slice is you can actually just create a new feature folder and just write the new version of the feature alongside the existing one, okay? Because you just write it as new code. There's no coupling going on here. We don't have to worry about linking with anything else. We just write the new feature, right, in the new way. And then what's really nice is I can just delete the old feature folder and off we go because it's not coupled to anything. So clearing up is as simple as pressing delete. Now that is, I appreciate this is certainly a bit of a niche thing. I'm not saying you're going to be doing this every other day, but it's something that you can do. Now perhaps a more interesting scenario that we could talk about here is A/B testing. So say you've got a couple of ways that you could approach a feature and you're not sure, maybe you're thinking about performance here and you're not sure what the best approach is or what have you. What you could do is write two versions of the feature. Now, in this case, you might want to share some UI between the two because that can be your code path switching at that point. And you can use feature flags and literally just go down 50% users one way, 50% the other, and you can just see which one works the best. And then once you've got that data, you can make that decision. And once again, when you know the one you want, you just delete the other one. Get rid of that code switch path in the UI, and off you go. So it's very simple to do this type of stuff. Right. Let's check out some code. I've been talking a lot about slides. This is just going to be a bit of an overview, just to kind of give you a bit of an idea about what this can look like in an application, okay? So this is kind of the thing you're going to be looking. Obviously, this is just an application I put together for the sake of this talk. There might be more going on here in a real-world application, but it's just to give you a kind of flavor for what this looks like. So like I said, you've got, in this case, I've got a Blazor app, and then I've got a features folder, and under that features folder, I've got the capabilities of this system. Now, this is kind of almost harks as well a bit to this concept that I saw once called screaming architecture, which is the architecture to scream at you what the application does. And I like this because this tells me it's a repairs application. I can see it because I can create a repair and I can list them and things like that. So these little things are also quite useful. If we look at what these kind of look like, and if I open a few of these folders, they kind of look the same, right? So this is what I was talking about earlier about the idea that you can build each feature optimally. And I was saying about some people are worried where it creates all these different patterns. Well, it doesn't. That doesn't really tend to happen. It tends to just kind of look like this. And that is that, you have some UI. In this case, it could be an API endpoint as well. Don't get me wrong. And then you have a class that's going to do whatever you need that particular feature to do. And then, again, depending on how you code it, you might have more than one class. It all depends. So this is kind of the general thing. So I've got a create repair page, and then I've got a save repair class that's going to actually deal with saving that wherever it needs to go, or any other logic that needs to happen as part of that action. Likewise, for the list repair page, I've got a get all repairs class that's going to go and get that data from wherever it needs to, and same with the view repair. So this is quite repetitive. It looks very similar. And like I say, everything to do with these features is just in these folders. So if I'm ever told to go and work on the view repair page and update a feature, I can be comfortable knowing that that is the only folder I need to go and look at. Now, there are alternative ways that you can do this, okay? So this big kind of flat structure might work for you, it might not. It's up to you. Another approach that you can do is kind of grouping things by area of your application. This is kind of useful when you've got a much bigger application. So this manage engineers, for example, right? This is a slightly different approach to how you can organize things. So in this case, I've got a manage engineers page, and that's got multiple actions that a user can do on it. So I've structured it this way, and I've said, right, well, in the root of that folder, I've got the page that lists the engineers, and I've got the code that's going to go and get all the engineers in that get all engineers class. But I've also got the ability to create an engineer. There's a button on the page that allows me to create an engineer. So in this case, this application will pop open a modal and then save the engineer to the data store. So I've got the modal in that create folder, and I've got the class that's going to do the saving in there. Okay, so that's all nice and neat and tidy. And then on each row, I've got the ability to delete an engineer. So I've got a class in here that can delete an engineer. Now, this doesn't have any UI behind it. It's just you click the delete button, it goes, because no one's going to click that by mistake or anything. So we're just going to click that, it's going to go. So I've just got a class here that just does that delete, and that's all it needs. So that's all there is. So it's up to you how you structure these things, okay? It doesn't matter. So some of my colleagues have termed this sub-verticals or sub-features. It's up to you. It really doesn't matter, okay? But the point is that we're just grouping things by what they do. So coming back to sort of some of the issues we talked about earlier about those commercial pressures, how do they affect vertical slice architecture? Because they certainly affect it, because they affect everything. These things don't change. By choosing vertical slice, we don't kind of change the way business works or anything like that. So let's have a talk through that. So we talked about rush features and the fact that this can create technical debt and problems in the system because we have to write some pretty gnarly code potentially. Well, in vertical slice, you probably are still going to do that, right? That's still not going to go away. The difference now, though, is it's contained within a feature. It's contained within one of those folders. It's not going to sprawl out across the system. If you have to make that gnarly bit of code in one of those services and that's called by 20 different places in the app, now 20 different places are affected by that gnarly bit of code, right? But because we've got everything self-contained in these verticals, if you write gnarly code, it stays there. Okay, so it's more contained. Custom functionality, yeah, you're probably still going to do that as well. But I think vertical slice actually offers a much better solution to this problem. I talked a second ago, didn't I, about the whole A/B testing thing. Well, that will also work for this scenario. Okay, we can write two versions of the feature, the custom one for customer A, and then the standard version for everyone else. And we can just maybe share the UI and have that branch between, or whatever happens to be the thing above it. Whether you're writing a CLI application or a service or whatever. And we can branch the code at that point, and you still have that warm fuzzy feeling when you write the if customer A do this, if customer B. You don't lose that. Don't worry, but at least the code is now more organized because everything for customer A is in that folder and everything for everyone else is over here. It makes it a little bit easier to understand. All right. So I think that is an improvement on it. And then there's this technical debt thing. Well, again, I think vertical slice offers more chance that you're going to get on top of this. And that's because everything is self-contained. When you do go and refactor things, you're doing it in a much more micro scale. All right? When you have to refactor that service that's touching 20 different places, you have to think about all of that when you're doing that change and trying to improve it. All right? And that's going to take more effort. It's going to take more time. But you've got a feature here that's isolated from everything else, which means that you can be quite aggressive with refactoring it, knowing that it's not going to have side effects elsewhere in your system. So again, I'm not saying it's all sunshine and rainbows, but I think it's definitely giving you more of a chance of getting on top of those problems, or at least keeping them in check. Now, when I was showing you those examples, I didn't go any code files, okay? One is because they haven't got anything in them, because I didn't have time to actually write a real application for this. And two is because, frankly, it doesn't really matter how you implement it. That's up to you. But I will tell you the way that I like to do things. And that is using CQRS. Now, this is actually what the path me and my team were on with clean architecture when I came across vertical slices. We were using CQRS. And CQRS, if anyone is unaware, stands for Command Query Responsibility Segregation. And essentially what we're doing here is splitting our code into code that is a command, which mutates state. So it's updates, saves, deletes, and queries that read state. So essentially your gets. All right? And we were doing this in our clean architecture approach, and we were just finding that we were kind of having this repeated pattern of we were just having these commands and queries, and that was actually creating these almost verticals across these layers, right? And really the big shine moment for me with vertical slices was, oh, I can just get rid of the layers now and just keep those verticals I've got, and things hopefully should be a bit more rosy. Now, what does this actually look like? Well, we can do it this way. You can do like something like a record type, and you can have that define a request. So in this case, I've got a page that's going to show me an engineer. So I've got this view engineer request, and it takes the engineer ID. And that will get dispatched to something called a handler. And that handler method, however you choose to do this, is going to take that request in. It's going to talk to your database, whatever it happens to be, get that data back, and then it's going to form a response. And that response is going to be tailored to the UI because, you know, we're just doing this for this one area. This is not generic, so you can make it exactly what that UI needs it to be. And in this case, we just need name, trade, and area, so we can return those values back. And off we go. If we want to be super, you know, clean about this, we could even change our EF query to make sure that we only return those things back from the database, and all that we can optimize to our heart's content. And then, as I said, that response then gets returned back to the calling code in the UI, in this case. Now, to some of you, you might be looking at that and thinking, oh, I recognize that. And for anyone who's not aware, that is Mediator. This is actually a library I've used for quite a number of years, and again, it's from Jimmy Bogard. I've tried to keep a little bit of distance between vertical slice and this and when I'm introducing it, because I don't want you to think that you have to use CQRS and Mediator to do vertical slice. You absolutely don't. You don't need to do any of this. If you don't like CQRS, you can just build, you know, your logic however you want to build it in order to fulfill your features. That's absolutely fine. This is just a way that I've found that's been very useful, and it's been a very clean way of doing things. Right, let me come back to this topic of code sharing. Okay, I mentioned earlier that generally speaking, you want to be thinking that you don't share code in vertical slice. And that's definitely a good way to start off and start thinking about things. But the reality is, of course, you are going to have shared code at some point. And you should have shared code. As I said earlier, I've not got a problem with sharing code. I don't think shared code is a bad thing. I think we do it too often, and I think there's a lot of things we share that aren't actually shareable. Okay? So I want to try and outline what I mean when I say what is shareable code, what is code sharing. So some criteria I kind of thought about here. Well, this might seem obvious, but it needs to do exactly the same thing, right? And it needs to do the same thing in multiple places. And when I say exactly the same thing, I want to emphasize the word exactly, right? I had an interesting discussion with some engineers once where I asked them, if you've got, you know, a piece of code and it's returning something, and then you want to use another piece of code wants to use it, but it maybe needs an extra property, do you think that code is shareable? And the resounding answer from all of them was yes. I was like, but it's not doing the same thing. That one wants the property with, or an object with 4 properties on it, and this one wants an object with 5 properties on it. They're not the same. Well, yeah, I know, but it's mostly the same. So it's not exactly the same. And the interesting thing here is that chances are, if they're not exactly the same now, they're just going to diverge further over time. So if you decide to share that code at that point, you've created this coupling that now has got more than one reason to change. And that's not good. So exactly the same thing. And unsurprisingly, that means that it should have the same inputs and the same outputs. Okay? If it needs those. It depends what you're doing, obviously. And finally, as I mentioned a second ago, it needs one reason to change. The moment you have shared code that has more than one reason to change, you have a problem. Now, this, with the best one in the world, you might share code and that still happens at some point, okay? But that's the point you need to be well aware of this, and you need to be very skilled at refactoring. You need to be very good at going, right, that thing now has more than one reason to change, we need to split it, okay? And the last bit of advice I would give on this is the rule of 3. I will not share code until I've got 3 examples of it being used, because that means that it's definitely reusable code. It's definitely being used in more than one place. If it's only being used in 2 places, frankly, I might take the duplication over sharing, because as I mentioned earlier, duplication can be cheaper than creating that coupling. So, how do you share this code? Well, all the standard ways you would share it in any other architecture. You can use extension methods. I use extension methods a lot. They're a great way of sharing code around your application. That's one method you could use. Another method you could use is refactoring to functions. Now, this is, frankly, every time I say this, this is horrible. I've not described this very well. Let me show you a code example. I'm basically trying to dodge the word service there, right? Because what I don't want to do is refactor things to a service, because we all know where that goes. So what I'm trying to get across when I say refactoring to a function is make something specific. Okay, so in this case, if I want to send invoices from multiple areas in this particular given application, I'm not saying that should be a good thing, but let's pretend for argument's sake it is, right? I don't want to go and create an invoice service, because what will happen is it will start with the send invoice method, excuse me, and then it will end up with the get invoice method and get invoices, and before I know it, it's 5,000 lines long, right? And I don't want that to happen. So instead, what I want to do is do something more specific, like I want to create a billing processor that has a public method, one public method, that sends an invoice. And that's it. Give it a specific purpose, give it one reason to change. And another, and kind of the final way that I would share code is using domains, okay? So I mentioned earlier I'm a fan of domain-driven design. I think it's a great way of modeling applications. So a lot of the time, most of the shared code that you're actually going to be looking at is actually business logic, business rules, and a domain is a great place to have those. You can encapsulate those into your aggregates, into your entities, okay, and you can have your verticals talk to those, and that way you can keep your business rules all straight in one place, and it's basically means that you don't have to encapsulate that into those verticals. So that is a very, very good way of sharing code as well. The last point I want to make on code sharing before we finish up is that, and I'm going to say this because this is something I've seen in comments on videos and on posts about vertical slice, is that you do not have to go and create your database access code in every vertical. You don't need to do that. If you're going to send emails, you do not have to write that in every vertical. Those are things, feel free to do those as share code from the offset, all right? That is not a thing. For some reason, some people have construed this idea that means that if you're having these external infrastructure concerns, they should be duplicated across every vertical. That is not what we're getting at here, all right? It's really, we're talking about that shared business logic and kind of these monolithic services and trying to make sure we avoid those, okay? Right, I think we're at time. So thank you very much for your time this morning. Please enjoy the rest of the conference. Have a safe journey home.